Section 6.3, number 45, we're going to use factoring to find all the real solutions in this and give our answer in radians. So looking at this, what can I factor? The first thing I do when I try to factor is look for if there's a greatest common factor. And there is here. I'm going to pull out this cosine of x. And what I'm left with, after pulling the factor of cosine out, is divide that first piece by cosine, I get 2 sine of x, and then divide that second piece, I get -1. That is all still equal to 0. Now the zero product property comes into here, so I have two numbers that are multiplied together to be 0. Either cosine of x is 0, or 2 sine minus 1 equals 0. When two numbers multiply together, when you get a product that equals 0, one of those numbers must be 0. So I'm going to set up two equations. 2 sine of x minus 1 equals 0, and cosine of x equals 0, and just solve both of them. Those are two different possibilities for x. So taking the cosine inverse of the left gives me x, so I'll do the same thing on the right. Cosine inverse of 0. I look at my unit circle. I'm going to find my answer in all reals, but starting with just the unit circle, and then we can add the periods. So looking at my unit circle, I have the cosine is 0 at pi over 2 and 3 pi over 2. And it's going to repeat, so this one repeats every 2 pi, and this with k as any integer, and this one repeats every 2 pi. But what I'm noticing is that since these are actually at a peak, these are actually separated by pi anyway. So really I can express this whole answer as pi over 2 plus any multiple of pi or minus. So k can be any integer. So it repeats on that cycle. Every pi it repeats again. So there's my answer for that side. And then for my other answers, I get, I'm looking at the light blue now, 2 sine of x minus 1 equals 0 gives me 2 sine of x equals 1. Divide both sides by 2, I get sine of x equals 1/2. Then if I take sine inverse of both sides, I get x equals, and looking again at my unit circle, I want my answer in all reals, but starting with just the unit circle, and then we'll add on the period. Sine is 1/2 at pi over 6 and 5 pi over 6. And to each of these, I will add the multiple of the period. So that's the period times k, where k is any integer, positive or negative. So that repeats every 2 pi. So on the purple solution on the left, I just consolidated those two solutions for pi over 2 and 3 pi over 2 by adding pi, since that period is the same. And on the right, they're spaced differently, so I need to separate them out. So I end up with 3 solutions for x.